At some point in the distant past, a human being put on clothes for the very first time. Not because someone told them to. Not because it was fashionable. For reasons that were probably urgent, uncomfortable, and nothing like what most people assume. And the story of how that happened is a lot stranger and more interesting than it sounds. The obvious answer is that early humans got cold, so they wrapped themselves in animal hides. That's the version most people carry around. But that explanation falls apart almost immediately when you start looking at the evidence. Because the timeline doesn't work. The first clothing didn't appear at the same moment humans moved into cold environments. The gap between those two events is hundreds of thousands of years. So something else was going on, and figuring out what that was requires working backward from some genuinely surprising places. Let's start with lice. Specifically body lice. You might not think of lice as a historical source, but they turned out to be one of the most useful clues researchers have ever found on this question. Human head lice and body lice are closely related, but they're not the same thing. Head lice live in hair, body lice live in clothing, and body lice can only survive and reproduce by clinging to fabric or woven material. They can't exist without it. So whenever body lice first split off from head lice and became their own distinct population, that's roughly when clothing had to have appeared. In 2011, a team of researchers used genetic sequencing to trace that split, and they came up with a date of somewhere around 170,000 years ago. That puts the origin of clothing in the middle of a period called marine isotope stage 6, one of the coldest and harshest glacial periods in the last 500,000 years. The timing wasn't accidental. The genetic analysis itself was meticulous work. Researchers examined mitochondrial DNA from both head and body lice specimens, looking at the mutations that had accumulated since the two populations diverged. The more mutations present, the longer ago the split occurred. What made this method so powerful was its precision. These microscopic creatures left no fossils, no artifacts, no direct evidence in the archaeological record, yet their genetics carried a timestamp written in mutations that scientists could read with remarkable accuracy. The 170,000-year date wasn't a rough estimate. It was based on actual biological clocks ticking inside louse DNA. And when researchers compared that date to everything else they knew about human history, the alignment was striking. Around 195,000 years ago, a dramatic climate shift swept across Africa. What had been relatively stable, resource-rich environments became dramatically colder and drier. Coastlines contracted. Forests shrank. The interior of the continent became nearly uninhabitable. Modern humans, Homo sapiens, were only a few tens of thousands of years old at this point, and their population collapsed. Genetic evidence suggests our entire species may have been reduced to a few thousand individuals, possibly fewer, clustered near the southern coast of Africa, where shellfish and marine resources kept them alive. In that context, any advantage in heat retention wasn't a luxury. It was the difference between surviving another winter and not. So clothing almost certainly started as protection from the cold. But here's where it gets complicated. Archaeologists haven't found clothing from 170,000 years ago, and they almost certainly never will. Organic materials don't preserve over those timescales, under most conditions. Fabric rots, animal hides decompose. What researchers have instead are indirect clues, and piecing those clues together is most of the challenge. One of the most important comes not from clothing itself, but from the tools used to make it. Scrapers are some of the oldest and most common stone tools in the archaeological record. Early humans used them for all kinds of tasks, including processing animal hides. But around 100,000 years ago, certain sites in Africa start showing a shift in scraper design. The tools become more refined, more specialized, better suited to the careful work of thinning and softening leather. At a site called Pinnacle Point in South Africa and at Blombos Cave, researchers have found assemblages of tools that suggest increasingly sophisticated material processing. The hides had to be worked repeatedly to become soft enough to wear without causing injury. That takes time, skill, and specific equipment. The variety in scraper types is itself informative. Not all stone scrapers were created equal, and early toolmakers understood these distinctions deeply. Some scrapers were sharp-edged, designed for the initial removal of tissue and fat. Others were more blunt, meant for the stretching and smoothing work that came later. The presence of this specialized toolkit suggests that hide processing had become a recognized craft, with practitioners who knew which tool did what and when to use it. The fact that these tools appear with increasing sophistication suggests knowledge being accumulated and passed down, refined through generations of trial and error into a genuinely skilled practice. Now, let's talk about what clothing actually required of the humans making it. Processing an animal hide into something wearable isn't simple. You have to scrape away the tissue and fat on the inner surface without puncturing the skin. Then you have to stretch it, dry it, and work it repeatedly to prevent it from stiffening into a board when it dries. In many traditional societies, this process alone can take days of continuous labor. And if you want to sew pieces together, you need a needle. The oldest known bone needles date to around 50,000 years ago in Siberia, from a site associated with Denisovans. That single artifact tells you that at least one human species had moved well past simply draping animal hides over their shoulders. They were cutting, shaping, and stitching fabric into fitted pieces. Why does that distinction matter? Because a fitted garment is dramatically more effective in cold conditions than a loose hide. Think about it like insulation in a house. Loose insulation works, but insulation that's properly installed and sealed keeps in far more heat. A sewn garment traps air against the body, moves with the person wearing it, and doesn't shed or slip when the wind picks up. The jump from draped hide to sewn clothing wasn't just a cultural refinement. It was a functional leap that opened up environments that would otherwise have been lethal. And that leap seems to have happened right around the time modern humans began pushing into northeastern Asia and eventually into the Americas. The Bering Land Bridge, the now submerged stretch of land connecting Siberia to Alaska, would have exposed early migrants to some of the most brutal cold on the planet. Average winter temperatures in that region during the last glacial maximum dropped well below what exposed skin can handle for any meaningful length of time. Without sophisticated fitted sewn clothing, crossing that landscape probably wasn't survivable. The needle, in other words, may have been as important to the peopling of the Americas as any other technology humans carried with them. But cold wasn't the only pressure driving early clothing use. There's a second thread running through this story, and it involves something researchers have spent a lot of time debating. Were there social or symbolic reasons for wearing clothing that developed separately from, or even alongside, the practical ones? The evidence here is thinner, but it's real. At sites across Africa dating to between 100,000 and 75,000 years ago, researchers have found perforated shells that were almost certainly worn as beads. Ochre, a red pigment, was ground and used to mark the body. These are behaviors that suggest early humans were already thinking about how they appeared to others, already using materials to signal identity or group membership or status. If you're already decorating your body with pigment and shells, the leap to decorating or shaping what you wear over your body isn't enormous. Some researchers argue that clothing probably took on social meaning very quickly, possibly almost from the beginning. There's also a thermoregulation argument that cuts in an unexpected direction. Modern humans, unlike many other primates, are nearly hairless. That hairlessness is actually an adaptation for heat dissipation. Running and sustained physical activity across open savanna environments generates enormous amounts of body heat, and losing body hair allowed early humans to sweat efficiently and cool down fast. But that same hairlessness created a vulnerability in cold conditions that other primates didn't face in the same way. Neanderthals, for instance, were built for cold. Their compact, stocky bodies were shaped by hundreds of thousands of years of European Ice Age climates. Modern humans came from equatorial Africa with a very different body plan, and clothing was part of how they compensated. Let's talk about what the fiber evidence tells us. Plant-based fibers are even harder to preserve than animal hides, but in 2009, researchers working in a cave in the Republic of Georgia called Dzudzuana found flax fibers that had been twisted, cut, and in some cases died. The fibers dated to around 34,000 years ago. That's not just hide working, that's the deliberate processing of plant material into something that could be woven or twisted into cordage or cloth. Dyed fibers mean the people making them cared about color, which points again toward a social or symbolic dimension layered on top of the practical one. Spinning and weaving technology, once it appeared, moved quickly. By around 27,000 years ago, impressions of woven fabric have been found pressed into fired clay at sites in the Czech Republic. The weaves were fine enough to produce lightweight textiles, not just heavy protective gear. People were making fabric that ranged from functional to delicate, and that range suggests clothing had already diversified into multiple purposes. Protection from cold was still the foundation, but it wasn't the whole story anymore. What's genuinely striking about the clothing timeline is how it maps onto the broader story of human expansion. Every time modern humans pushed into a new, harsh environment, the archaeological record tends to show more sophisticated material culture around the same period. Better tools, more complex processing techniques, evidence of longer planning horizons. Clothing wasn't invented once and then forgotten about. It kept getting better, kept getting more refined, kept being adapted to whatever the next environment demanded. By around 25,000 years ago, at the peak of the last glacial maximum, humans were living at latitudes that receive almost no solar warmth for months at a time. Sites from this period in Russia, Ukraine, and the Czech Republic show evidence of layered clothing construction, with different materials used for inner and outer layers. That's not a random development. Layering is a specific cold weather strategy that traps insulating air between layers while allowing moisture to escape. Whoever figured that out understood something precise about how heat works, even if they had no formal language for it. There's one more layer to this story worth sitting with. The oldest known sewing needles, the ones from Denisova cave in Siberia, dating to around 50,000 years ago, weren't made by modern humans. They were made by Denisovans, the same mysterious population whose entire physical record fits inside a finger bone and a few teeth. The Denisovans were spread across a vast territory stretching from Siberia down into Southeast Asia, and they were doing this in some of the most inhospitable terrain on the planet. Their clothing technology may have been as sophisticated as anything modern humans were producing at the same time, and they'd been at it for a very long time. When modern humans eventually moved into those territories and interbred with Denisovans, they didn't just pick up genes, they almost certainly picked up knowledge. Techniques for processing hides, methods for sewing, strategies for surviving cold that Denisovans had spent tens of thousands of years working out. Cultural exchange of that kind is hard to find in the fossil record, but the genetic overlap between modern humans and Denisovans in high altitude and cold adapted populations is hard to explain without it. So the full picture looks something like this. Around 170,000 years ago, possibly earlier, humans in southern Africa began using animal hides to protect themselves from a severe cold period that had compressed their population to the edge of extinction. Over the following tens of thousands of years, the technology improved. Hide-working tools became more specialized. Sewing needles appeared. Plant fibers were twisted and dyed. And as the technology improved, clothing started carrying social meaning alongside its practical function. By the time modern humans began crossing into the coldest parts of Eurasia and eventually into the Americas, sewn, fitted, layered clothing was part of what made those journeys survivable. The lice hitched a ride. The needles went with them. And at every step, the thing that started as a response to a cold snap in Africa became one of the defining technologies of the species.